Hello, welcome guys. So today we will be discussing two problems from 2015 while IIT JAM paper. One's from MLE stuff, another is from consistency and a bit of estimation. Okay, so let's see and explore the problems together. So let's go to the problem three. The problem three says this is also a demo like problem solving session. We are sort of I'm giving you so that you understand the for the like how we are going to discuss problems for the problem solving crash course of 2021. Okay, that we are sort of launching from the next week. Anyways, let's move ahead and directly go deep into the problem. So x is a single observation from binomial 1 comma p, where p is 1 by 5 comma 4 by 5. So essentially it's an information over here. It's a very important thing to like no, p is an information over here. So remember this. So we can sort of generalize this aspect over here. So let's see if the value of x is 0, then what is the maximum likelihood estimator of p? Okay, that's the idea. That's the question is all about. So when you're trying to do this, just go by the general form. Okay, just to go from the first principle. So don't try to apply theorems just as it is. Okay, just apply like the just do the basic stuff. Okay, understand in this manner. So the first write a likelihood. Okay, if you write a likelihood, you will get this simple idea that okay, likelihood is n choose 0 for the x is equal to 0, n choose 0, x is equal to 0, p to the power x, that is x is 0, and 1 minus p whole to the power n minus x. N is equal to 1 single observation, and therefore it's x equal to 0, so therefore it's 1. So it's get that 1 minus p. Now likelihood is 1 minus p is a function of the parameter, of course, but now it's given that p is from 1.1 comma 5 to 4 comma 5, so therefore we should see in that region only, right? So what do we get over here? So also if you draw lp, the likelihood with respect to p, it's a straight line like this joining 0 comma 1 and 1 comma 0. It's like a simple high school mathematics, and it's decreasing over here, right? And therefore it's maximum at p is equal to 1 comma 1 by 5, right? That's the beautiful part. So therefore you get that the likelihood the MLE happens at p is equal to 1 by 5. Okay, and of course you can see it's like that's the idea. Okay, if like in that case it will be 0 usually, p is equal to 0, because it's observed as 0, right? So therefore if there was no restriction, it would have been 0 over here, which also makes sense logically. So now an extension of the problem you can do, we'll discuss the extension in the classes also, that what if there are n observations or 3 observations are given, how can you really find out, and what if it's general, just do the general part of it, x1 x2 xn from binomial n comma p, and then how will you what is the really maximum likelihood estimator of p? It's x bar, right? But what if p is given over there? Okay, how do you incorporate that idea of p is given over there? Okay, then it wouldn't have been x bar, right? It would have been something else. So just apply that without it's x bar, with the information, with the general category of like interval of values for p. How will you find out the maximum likely estimator? Okay, so this is a beautiful like small cute little problem from Emily, and you have to understand we should minimize the like maximize the likelihood, and therefore we get the maximum likelihood estimator. So that's how you, I hope you know the theory about this. Okay, so that's the thing, these are the things we will discuss and revise in the classes so that it becomes clear to you. Let me show something about the class, that about the things we are going to organize, like the corresponding course we are going to organize. Let's see. Okay, so this is a crash course we're going to organize. So we are organizing this IIT JAM MS 2021 problem solving crash course, and this will be held twice a week, and class notes will be given almost each class of 1.5 hours, and we'll be discussing these problems with full details, all the results and all the focused path that is required for IIT JAM, all the techniques used, and observe that um, we will be there will be two classes. So I will be focusing on the statistics part mainly, and Shom will be focusing on the non-statistics, the probability real analysis main part, linear algebra, this stuff. So we'll be discussing a compact stuff so that you get prepared for the whole things, whole concepts, whole everything together. And this is of course left for this current student of ours, is extra for those who are trying to prepare for IIT JAM at the last moment. Okay, so all the best guys, and okay, so let's get back to the last problem. And if you need some information, let me know. You see the number over there, like ping in the WhatsApp in that number, and yeah, so if you have any like queries, you can always ping this number, and I will be the person getting back to you. All the best, guys, and let's move on to the next problem. Okay, so the next problem, so we have discussed this problem in one of the videos. This problem, the last video, 10th problem. It's a really interesting problem. It like sort of helps you understand everything, every bits and bits about the normal parameter estimation part. So let's see this problem. So xi and sits from unbiasedness and estimated mean. Xi are random sample from normal theta comma theta square. It's a curved exponential family. I mean, because the parameters are dependent upon each other. So if you just draw this, it will be like, if you draw mu on sigma square, it will be like this, theta and theta square. So that's why it's called curve anyways. So of course theta is unknown, and you have two estimators, ti is summation xi and t2 is summation xi square. So if you know for its mu and sigma square, these are complete and sufficient. Okay, so these things are really like, not like, these things are really important bits and bits, so that it helps you like really focus and remember the theories and the class that are really like based on this. Okay, so remember about this, remember all of this, and we will be like sparking all these memories for your exam purposes. So let's focus. T1 and T2 are given, and we need to find the unbiased criteria, and we need to find the consistency criteria among these estimators. So observe this expression. Let's find expression of T1. So xi have mean theta, so expression of T1 will be n theta, and variance of T1 will be n theta square, right? Because variance of xi are theta square. Okay, and xi is an IID, so the independence of the covariance term will be 0. So therefore, these things two terms are natural. And if you do variance of T1 by n, okay, so rather let's do variance of T1 square. If to vary, so let's do the expression of T1 square. Sorry. So if you do the expression of T1 square, that's why we did variance over here, because variance is equal to expression of T1 square minus expression of T1 whole square. So you get expression of T1 square is equal to variance of T1 plus expression of T1 whole square, which gives rise to n theta square plus n square theta square, which gives us n into n plus 1 theta square. So therefore, if you divide by n square, T1 square by n square, you don't get, it's not unbiased. Okay, rather what is unbiased is T1 square by n into n plus 1 is unbiased, not this. So therefore, this is not true. Okay, but is it consistent? Let's check. So T1 square, T1 is by n is equal to summation xi by n, and by like SLN, like it converts in probability to summation of expression of I, right? Expression of um like it converts in probability in some, it's not SLN but WLN, it converts in probability expectation of xi, which is equal to theta, right? So therefore T1 by n converges in probability to theta, and therefore if theta had theta n converges in probability to theta, then theta n whole square also converges in probability to theta square. So that's why the property of the in probability convergence. So therefore this is consistent for theta square. Okay. Also, you can sort of think in this manner that expression of this is this. If you just divide by n square, sort of n square and n square plus n into n square plus 1, n into n plus 1 is sort of PFSM in the infinite way. Okay. So therefore, even its expectation also be converging towards that theta square in the long run. Okay. So that's also, you can think in that manner. Okay. If you want to think in that manner, expectation, or if you do directly in this aspect, okay, without doing this, applying this one, essentially the proof is essentially the same. So you can also think it like this, that T1 square. Anyways, so let's not be into that, deep into that. Let's do the T2 square now. T2 fall apart now. Summation of T2. Let's take expectation. So T2 is observed by the, if you do the expectation, it's n times expectation of x1 whole square. Expression of x1 whole square is what? Variance of x1 plus expression of x1 whole uska whole square. So therefore you get theta square and theta square both, right? So you get n twice n theta square, and if we do expression of T2 by 2n, then you get theta square. Therefore, it's unbiased for theta square. Unbiased. So that's how you get, and therefore let's apply again WLN over here. So T2 by n is summation xi square by n, which by WLN again converges to expression of x1 whole square. Expression of x1 whole square is from here is twice theta square, right? So therefore, if you just take 2 this side, you get t2 by 2n converges in probability by 2 theta square. So therefore, it's also consistent for theta square. So that's it. So that's a like yeah. Please, if you don't remember consistency, just revise a spread of confidence consistency. Just remember that theta n minus iska less than epsilon iska probability is 1. Okay, these are the definitions of consistency, and there are a lot of interesting results. So usually when it's asked for consistency, apply this basic WLN part and also apply the basic aspects of this definition. Okay, sometimes the definition is really useful because it can help you to compute stuff, okay, directly from that. So we can do this small problems in this class, and it also enhances your knowledge base. Okay, so stay tuned, stay blessed, and let's for the next video with exciting problems. Good night.